the stationary, we have seen the graph is something like this. Okay, okay, and yes, and this is what, this is the distance and this is the time for all. Distance, time, distance, time. Alright. And also one thing, we have already understood that why we have represented the distance on the y-axis, why not on the x? Because on x-axis we generally represent the independent quantities, and the time is on only the independent quantities. It doesn't depend on the any physical quantities. Okay, whereas the distance is the dependent quantities. So dependent quantities are always represented on the y-axis. Okay, all right. So moving on, next we will see the equation. Okay, we will see equation of motion through graph only. Okay, all right. So equation of motion. Okay, so what we have seen so far is the distance, which is represented by what? The s. The speed, which we have seen, is represented by u v only. The velocity, so velocity is of two types, initial and the final. So the initial is represented with u, small u, and the final velocity is represented by v. Okay. The fourth one is, we have seen the acceleration, which is represented by small a, right? Alright, and the time, very important, which is represented by t. Okay. So as far we have seen this much quantity. Okay. And also we have seen that a equals to the initial velocity minus okay, so acceleration equals final velocity minus initial velocity by the time. Okay, so acceleration is what? The change in velocity in unit time. Okay, alright, so this much we have already studied. So we have to check out the equation of motion through graph. Okay, so let's have the graph for what? For velocity time relation. Okay, for velocity time relation we will see that, let's say it's a velocity and it's a time. Okay, so for instance, the initial velocity is somewhere here and the final velocity is somewhere here. Okay, from this the body moves to a certain distance in particular time, so it reaches to the final velocity. Okay, let's draw a straight line to this and mark this arbitrary point. Okay, so alright, so this is A, this is B, this is C, this is D, this is A, and this is, let's say, F. Okay, alright, are you clear with this figure? Alright, so if we talk about the length in let's say in rectangle ACDE, we can say that AE equals to CD, which is nothing but U, right? And ED equals AC, which we can write as T also. Similarly, if we talk about EF is equals, we also can write as BD, which is V. Alright? So, alright. From all this, okay. If we talk about in triangle you can say, if you see AB is what? The gradient. Okay? And you know that the gradient is what? Change in y by change in x. Okay? So, what is the change in y for this? Is y is what changing? CBC. Okay? And change in x is what? AC. Alright. So, from here, AB, okay. And also you know that AB is equals gradient, and gradient is nothing but in velocity time graph, it's a acceleration, right? Sorry. Okay, acceleration. Because change in y is what? Change in y is what? You can say the v minus u. This is what changing over here, right? In BC. So if you talk about A equals BC. So BC is what? D minus U by AC. AC is what? The T. Okay. So from here we can write this as A equals B minus U by T. So V minus U equals, we can write AT, and from here we can conclude that D equals to U plus AT. This is the equation of motion. It's an first equation, right? Did you get this all? Okay, just have a look for a second. Alright, so the second equation is, second relation is for what? Position time. Position time. Okay. Position time relation. Let us see. Okay. So from the given graph. Okay. Let's say S is what the position, or you can say the distance. Okay. And T is the time. Okay. And A is the acceleration, which is uniform. Okay. Alright. So to get this relation, what we can do is, one thing more, if we talk about this area, this area is nothing but represent distance traveled only. Okay, so distance traveled equals area of the triangle, you can say ABC plus area of ACED. Okay, so area of triangle ABC is what? If we talk about the area of this triangle, it is what? Half into base. So base is what? AC into the height is what? BC. Okay, plus area of the rectangle, which you can say that AE into ED. Okay, alright. So let us see about these distances. So if we talk about AC, the AC is just equivalent to ED, which is what? The time T, right? Again, if we talk about BC, so the BC is what? The change of velocity. Change of velocity, which is V minus U. Right? Now AE. So AE, if you see this, AE is what? U, and ED, where is ED? ED is what again? The time T. Okay. So let's substitute this. Let's substitute over here. So equals half into AC. Where is AC? AC into BC, E minus U, okay, plus AE and T. Alright. Now let us simplify it again. So one thing more, if you remember, like we have seen, A equals to E minus U by T. So from here, can we write V minus U equals to AT also? Right? So from here, we can just remove this with this value. So we can write as half T into AT plus UT. Okay. So the final equation we get is, the distance is what? S. So we can write as S equals half into AT square plus UT. And this is what? The equation of motion. And this is the second equation. Okay. Alright, let's have a look. Alright. So now our third equation of motion, we will see through the graph. Okay. So the relation is for velocity, and you can say that distance. Okay. So for velocity or distance, or you can say that what? The position and velocity also. In another word, okay. So these both terms are the same, okay. So let's see how. So we need to find the relation between the position and the velocity. So position is the what? The distance travel, okay, and the velocity, okay. As you know, this is what the distance travel, okay. So distance travel is what? The area of the trapezium, right? So Alright, let's see. So the distance travel is what? This is what the distance travel. Okay. So S is what? We can say that area of trapezium A, B, E, B. Okay. So area of trapezium is what? Half into sum of the opposite side. So sum of the opposite side is what? AE plus BD into the distance. The distance is what? AC. Okay. So let us replace all this. So AE plus BD. AE. Where is AE? AE. AE is what? Half into AE plus BD. BD. BD is what? B. So U plus B into AC. AC is what? The T. Okay. Let's say equation 1. Okay. Now, as we also know from this that A equals to B minus U by T. Okay. From A also we can write as the T equals B minus U by A also. This is the equation second. Right? So from these two equations, okay. So from equation 1 and equation 2, we replace the T in equation 1, so we can write as S equals to half U plus B, and we will replace T with this value in equation from equation second. So that is what? B minus U by A. Right? Are you clear with this till here? If any doubt, just write in the comments. Okay? So let's move on. Let's simplify it again. So we can say that S equals to half into what? If you multiply this, you will get U square. Okay. We will write V square plus V square minus U square by A. Right? Alright. So S equals to, we can write as B square minus U square by 2A, and again we will simplify it and we will get this B square minus U square equals to 2AS, or we can write V square equals to U square plus 2AS. So this is the third equation we get for the equation of motion. Okay. So just have a look for a second, then I'll conclude this. Okay. Alright. So now I'm concluding this. So far what we have discussed is that the first equation of motion, which is what? The position time relation, which we have done as what? B equals to U plus AT. Right? Now the second is what? The second is what we have done is like, and the second one we have done is like the position and time relation, which is S equals to half AT square plus UT. Okay. This is the second relation for motion, and the third and the last equation of motion relation, which is position and position and velocity relation, which is what? V square equals to U square plus 2AS. Okay. So this is what we have seen. Alright. So I hope you get all this. There are only 3 relations possible in equation of motion. Okay. So the first one is what? The velocity time relation. Second one is position time relation, and the third one is position velocity relation. Okay. These are the 3 equations of motion. Okay. Alright. If any doubt, just write in the comment and do subscribe my channel. Thank you so much.